Okay, so the first part of 2.1 we're going to take a look at has to do with angles and how we can measure them. So one unit that we've used to measure angles before in geometry, you're probably used to, is degrees. There's another unit that we can use that's more common in trig. Okay, we'll talk about what that unit is, and the goal is to learn how to convert between the two.
You're scared.
It'll be okay.
Okay.
Not well.
Before we even talk about how to measure an angle, I'm just going to talk about the two sides and what those are called in an angle. So when you draw an angle, there are two sides to it, and each side is called a ray. Right? So if you have a ray like this and another ray like that, that's how you can create an angle. The key is that when you draw the two rays, they have to start at the same point, and that point is called vertex. So that's the definition of an angle. It's two rays coming from the same point. Now, you can also have an angle inside of a shape, right? That's not the kind of angles that we're really talking about today. So when you draw something like this, the 90, the angle that I labeled 1 and 2, those are also angles. But in this case, these are not rays. What do we call those things?
Legs. A triangle.
So they are well, that's a leg, that's a hypotenuse, that's a leg.
Yeah.
But what
Sides.
shape are they?
Triangle. It's a triangle.
A right triangle.
A line.
No, it's not a line, because that would go on forever.
A line with 2 points on the end. A line segment.
A segment, yeah. So
You got there.
technically, when you're talking about a shape, you can have two line segments that make an angle. When you talk about an angle all by itself, it's two rays, not line segments. Okay. So a ray, basically, it extends in one direction forever. Putting the two rays together with a common vertex, that's the picture I drew up above. That gives you an angle.
So they can never end.
Yep, they never end. Obviously, when you're talking about an angle inside of like a triangle, the sides end.
Yeah.
That's different. But an angle just drawn by itself, basically just do something like that. Just keeps going. Right, there's another example. Now, each of these rays has a name because they make up the sides of the angle. One of them is called the initial side. One of them is called the terminal. If I just label them 1 and 2 for now, does anybody have a guess which one is the initial?
It's in one.
Yeah, and the 2 is the terminal. Yep. So an angle has an initial side and a terminal side.
How do you determine that?
So the way you can figure out which side is which is if you're standing in between the two rays and you rotate counterclockwise this way. Wherever you start, that's the initial. Wherever your arrow would end, that's the terminal. So if you had
So
an
it's
angle,
always to the left?
well, it depends how you draw your angle. So in that case, that's your initial, and that is your terminal.
What's a case where the terminal would be on the right?
So if you drew an angle like this, you're not really rotating left because you're rotating counterclockwise, like that. That's the initial. This is the terminal.
So are you always rotating?
To determine initial and terminal. Yep. You're always rotating in a direction like that. So as you rotate counterclockwise, wherever you start is the initial, wherever you end is the terminal. And it doesn't matter if I take all this and I group it and I spin that whole thing, the initial and terminal sides don't change.
And so it's turning counterclockwise?
Yeah, it's going counterclockwise. The side pointing up and to the left is still the initial, and the one going down and to the right is still the terminal.
Can you go up for 1 second? I just didn't get the words.
That one? Yep, if you put two rays together with a common vertex, that's how you create an angle. Now, out of all these angles that we've drawn, none of these, this one's close. This first one that has the blue box around it, that one's pretty good. But none of them are really drawn how they should be. Right? When you draw the initial side, the way we make it easy to figure out which side is initial is we try to make the initial side horizontal and always pointing to the right. That way it makes it easier to figure out. Drawing an angle like these two, that's not really a good way to do it. Right? So if I was going to draw this angle on the right, the best way to draw it would be facing that way. So the initial side is pointing to the right. Right? It's not wrong to put it a different way. It's just there's a name for that, and I'll show you that in a minute. Here's another example, and that's drawn well. Okay, the initial side is pointing to the right. Okay, when we start to measure an angle, okay, like the amount of rotation from the initial side to the terminal side, we can rotate two ways. Counterclockwise is one way. What would be the other one?
Clockwise.
Clockwise. Depending on which way you rotate is going to control whether your angle is a positive or a negative. So you can have negative angles. All that a negative angle means is you are rotating in a clockwise direction. Would you have a negative angle in a triangle? No, we normally don't. We don't talk about negative angles in that situation. But if you're just talking about an amount of rotation on a circle, you can go two different ways. Okay, so counterclockwise, just in case you're not sure, this is counterclockwise. And that's always positive angle. This is clockwise. That's a negative angle. All right, so what we're looking at here is a simple program that lets me draw angles. So I can't move the initial side. All I can do is move the terminal side. So as I move the terminal side in a counterclockwise direction, the angle starts to get bigger and bigger. There's two numbers that are measuring the angle. The top one has the little circle next to it, so that means degrees. The bottom one we'll talk about in a little bit. If I go all the way around, how many degrees would it be?
360 degrees.
Yep, 360 is all the way around. And then if I go past 360, it's an angle bigger than 360. Just means you went around more than once. Okay. If I put it back at 0 and I start going clockwise, it starts giving me negative angles. Halfway around in the clockwise direction would be like a negative 180. All right. Any questions on that direction?
It's like 345 on the clock. Negative 180.
So I told you that when you sketch an angle, to make the initial side easy to figure out, we normally draw it a certain way. All of the angles in this program have the initial side on the right part of the x-axis. If you draw your angle so that the initial side is on the x-axis and the vertex is at the origin, that's called standard position. That's how you normally would sketch an angle. So if I asked you to sketch a 90-degree angle in standard position, that's how you would do it. Okay. If you took that angle and you rotated it, I mean, it's still a 90, but that's not in standard position. Okay, so standard position, two things have to happen. Initial side is on the positive x-axis, means pointing to the right, and the vertex is at the origin. There's another example of an angle that's in standard position. Okay, what if I did this?
Not standard position.
No, what's wrong with it?
It's not the origin.
Hey, the initial side is okay.
Good job.
The initial side is on the x-axis, but the vertex isn't at the origin. How about if I did
Not standard position.
that?
Not standard position.
But the terminal side is on the y-axis.
But the initial side isn't on the x-axis.
Right, who cares about the terminal side? That's not in
We
the
don't
definition.
care about terminal side.
No. Okay. Vertex is at the origin, that's good. But the initial side should be on the positive x-axis. Just like that. Any question on that? Yes.
So why does it matter what side is what side?
What's just for reference, so if I'm saying like look at the terminal side and tell me the slope of it, just so you know which side I'm talking about.
Okay, so if you're like trying to find the slope or something.
Yeah, it just gives us a way to talk about each side.
Oh, let's never do
And
slope.
this is called
Wait.
what? It's called what?
It's called standard position. All right, so when I drew those angles in that program, you probably saw it, there were two numbers. There's that top one and then the
Oh, is one
bottom
days?
one. So the top one is degrees and the bottom one is radians.
I remember I got my calculator stuck on radians and not degrees or something.
Yep, and we're gonna talk about how you change the calculator to radians and degrees. Probably not today though.
That's okay.
So radians is just another way to measure an angle. It's a lot more common than degrees in trig. Okay, degrees is not used as much.
Why?
Because there's some formulas that we're going to use probably tomorrow, and the formula is a lot simpler in radians. If I do the formula in degrees, it gets a little more
Like
complicated.
how, what, never mind, you're probably gonna explain it.
So first, just by looking at the word radians, thinking about geometry.
Radius.
Does it look like any other word or have some letters in common?
Radius.
Yeah, it has R-A-D-I, that's how radius starts.
Radii.
So when I start to explain what a radian is, I'm going to explain it in terms of a circle because a radian and a radius are connected. All right, so this is what we have to figure out. Okay, in order to be able to convert between degrees and radians, we have to know that question mark.
Oh, and then you just like will divide by the rest.
Once you have a connection between two things, you can easily convert between them. For example, if I wanted to convert between feet and inches, all I need is a fact that connects feet to inches. It can be any fact that's true. So what's a fact that connects feet and inches? Anything that's true.
12 feet.
Is 12 inches.
1 foot is 12 inches.
I was gonna say 12 feet equals 140.
You could also say 12 feet is 144 inches.
So I would say 100
Okay.
feet.
It doesn't matter which one you use. Let's say you had 8
I was
feet,
gonna say 2 feet.
and you want to convert 8 feet to inches. If you know 1 foot has 12, then you can say 8 feet has, and then solve for x.
We could just environmental stuff.
The key here is you just have to start with a fact that's true on one side. Okay? Just have to start with something that's true. Doesn't matter if it's 1 over 12, 2 over 24, just has to be a fact that's true. So for us to convert between radians and degrees, we just have to find some connection that's true between degrees and radians. Any connection, okay? But it has to be something that's true. Once we know that, then we can easily convert.
So what is it? How many radians?
We're going to figure that out.
We don't just like get the baseline.
You don't just get the base.
How do you find it if you don't?
I think he's about to tell us.
I'm going to teach you. So let's start with this picture. This picture is not going to help us change between degrees and radians. What this picture is to help us kind of visualize how big a radian is. Okay. So to visualize it, what I want you to do is draw that circle.
My back?
Once
Don't take notes.
Once you draw that circle, we put an angle inside it. The angle, tried to put it at the center of the circle, and there's two rays coming from the center. When you draw a line from a center to the edge in a circle, what do you call it?
Radius.
It's a radius. Yep. That's why I labeled the length of each of those two things as r. Okay. I don't know how big they are, but they're the radius of the circle. Once you draw the radius of the circle, the two radii are going to hit the circle in different spots. Depends how big and small you make your angle. But that ray hits there, and that ray hits right there. Any question about those two dots? Now, connect the two dots. If you connect those two dots, that shape in red is an arc.
1,100.
Now, for that to be exactly 1 radian, something very special would have to happen. If the length of that arc in red, like if you took a piece of string, put it on that arc, measured it, straighten it out, put it on a ruler, and then you took a ruler and you measured the radius. If the arc in red and the radius in black came out exactly the same, then that would be exactly 1 radian.
So how does it?
How does that give us a rule? Wait.
To convert between radians and degrees?
Yeah, like how do I?
So I said right away that this picture was not going to help us convert between radians
Oh,
and degrees.
okay.
This picture is to visualize how big a radian roughly looks like. And that's drawn pretty to scale.
But like
Wait, so a radian is the same as
No.
a radius?
What's that?
A radian is the same length as a radius?
So a radian is the measure of the size of an angle. A radius is a measure of how wide a circle is.
so we can like
But they both measure something about a circle in this case.
Was one radian? Radius?
yeah, that's what I was gonna say is because
Yeah.
No, it's
so
a
like
whole thing.
those two lines are gonna be the same length the whole time around.
Yeah, these two lines in black would always be the same
So-
because they're from the center.
So we're gonna know how long that radian is the whole time just by knowing the length of those two lines. So if sorry, I don't maybe I.
I don't think I'm
Yeah,
understanding
I'm
either.
lost now.
So is it
I
a
don't understand
whole,
what
is it like a
radian-
triangle?
All right, I'm gonna let you continue on and then
I still don't
Yep.
understand what
I
radian.
have
I
an
don't understand what
unrelated
radian
question to
is.
whatever they're talking about. What happens when you change the size of the circle?
Then
That'll
it's
change the
not-
length of the thing.
No, if you change the size of the circle, the angle will not change because it will be similar.
No, the angle won't, but wouldn't the radian change?
Yeah, the radian would change, but in that picture, that's still 1 radian. Yes, the size of the radius changed, but the size of this angle did not.
So
Okay.
that's,
Yeah.
so
So, in order for you to draw an angle that is 1 radian, you have to draw a picture like that.
so an angle is a radian.
And the arc in red comes out exactly the same length as the radius.
So a radian is not a number, it's an angle?
Yeah, a radian is an angle. Yep. Now
So how
that,
can you have more than one?
that doesn't always have to come out to 1 radian. If I draw an angle like this, and I measure the length of my radius, and I measure the length of my
Oh,
arc,
and you divide?
would the length of the arc equal the radius in this
No.
case? No. Then that means that angle is not 1 radian.
So how do you divide, do you just divide by it, and then that's how many radians it is?
No.
I haven't shown you how to convert between radians and degrees yet.
Crazy
Yeah.
quadrant form.
Right now, we're just visualizing what a radian looks like. We're just practicing, like if we took our hands and went like this,
Oh.
how big should a radian be?
So a radian is an angle.
About like that. That's about 1 radian.
Like 4,500.
So
It's a little bigger than 45. It's in the 50s,
Yeah.
but it's close.
since the angle doesn't change for each circle, is the angle always the same?
Well, it depends on how far apart you make those two sides.
So all we need to do to figure out a radian is
No, a radian's an angle.
yeah, I know. So what angle is a radian?
We
It's
haven't.
the radius, or the.
So here's another picture. All I'm trying to show you right now is when you draw two lines like this, I'm trying to show you when you have drawn 1 radian and when
That's
you
not a
haven't.
radian.
That is not 1 radian.
Yeah, but you said it's about this, but like what exact degree?
We haven't learned that yet.
We have to figure out.
For now, we're just answering the question I said.
Okay.
We're just answering, if you draw 2 lines in a circle, does it look like 1 radian or does it not look like 1
I
radian?
understand.
That's all we're answering.
Okay.
So right now,
So much more complicated.
that is not 1 radian. Because
No.
if you measured the length of that part in red,
Too big.
and you measured that part in black, the red arc is a lot bigger. Right? And then if you draw a circle like this, draw an angle like that, does that look like 1 radian?
No, not one
No.
radian.
For it to be 1 radian, this part in red would have to be the same length as the part in blue. That's all I want you
But
to
that's still
understand.
part of a radian, is it not?
It's smaller than a radian, yeah, it might be.
So it'd be like point something radians?
Yeah,
Yes.
yep. So that's the connection between radian and radius. If the length of your arc is the same as your radius, then you've drawn a picture of 1 radian.
So,
If the length of your arc is not the same as your radius, you have not drawn a picture of 1 radian. You've drawn something else.
what
Nothing.
would that be?
We don't know. It wouldn't be 1 radian. It'd be
So you
some-
can have more or less than 1 radian, right?
Yeah, just like you can have more or less than 90 degrees. You can have 91, you can have
It
87.
would just be like 1.5 radians.
Yeah, you can have decimal radians.
Oh, so those are radians?
Mhm. You
But
can have
one.
you can have decimal amounts of radians. Yeah,
Can you go to 1 radian?
yeah. 1 radian is somewhere right around there, probably right about.
So 1 radian is 58, 57, 58.
Somewhere around there. Yeah. Somebody said 45 and I said a little bit bigger. But yeah, that's about 1 radian. Yeah.
So
So-
is the degree required for one radian, is that not a whole number?
Oh, it's not a whole number.
Okay.
No,
Put
it's,
radians on a compass.
no,
so we can just
it's
hold
not
it.
the number of degrees in 1 radian is not a nice number.
Okay.
No.
Like 57 point,
We're just
4.
confusing ourselves.
Yeah, it's
4
57 point something.
This has nothing to do with daylight savings.
All right. So now, what we want to be able to figure out is how we can convert between a radian and a degree. Okay, we have an idea of what 1 radian physically looks like. That's all I wanted to show you there. Now you're going to figure out how do we convert between the two. In order to do that, I've got to give you something to start with. Right? It's kind of like if I ask somebody, in like kindergarten, if they don't know how many feet in a mile, they're not going to be able to convert between feet and miles. They got to know,
Do you know how many feet are in a mile?
yes,
How many feet?
they have to know something about feet and miles. If you don't have any connection between the two, then you're stuck. So right now, you guys don't have a connection between radians and degrees. So I'm going to give you one. And we're going to draw this out and see if we can use this to figure out how many radians basically in one full circle. We know how many degrees in a full circle, I hope. Right? How many degrees in a full circle?
360 degrees.
Skippy says 365.
So we got to figure out how many radians. Okay. So let's read that, and then we got to break it down and maybe define one of those words that we might not know what it means. So it says that if you measure an angle using radians, if you measure an angle in radians, it will come out the same as the length of the arc, but only if you draw the circle to be a certain size.
Wait.
So if you measure an angle like this part right here in radians, that measurement will come out the same as the length of this arc
So the angle measurement. which
on a certain size circle.
is- Why not every circle?
Because it only works on this kind of circle.
A unit circle?
But that's okay. Even though it only works on this circle, that's all we needed to work with.
An angle that, are all circles the same?
No.
That's racist.
They
How
can
do you
be,
make a circle different than another circle?
well, that
without
circle
an
is
angle?
different from that circle.
Circle.
That's all wrong. Well, are oval circles?
No.
No.
So a unit circle is just a circle that is a certain size.
What size is it?
That's what I want to see if we know. Anybody have a
We
guess?
don't know. Is it 10 feet?
7.26.
No, it's
An
a
inch?
nice number.
An inch?
Yeah? What would be 2?
Two what?
2 inches.
Well, no, there's no unit with it. It's just going to be a number.
Two.
2 would be the what?
2 radius.
No, 2 would be the radius.
Two right.
2 would be the diameter.
Is it?
So what would be the radius?
2, 1.
1.
I
I'm
said
so
1.
smart. I got that first try.
So a unit circle is just a circle with a radius of 1. It's a certain size circle.
I see why none of us are
So
going.
who decided this?
I don't know.
You don't know?
Pythagorean.
Me.
Prometheus.
So a unit circle is a circle that has a radius of 1. So let's draw a circle.
What's the corresponding arc? Or what is a corresponding arc?
It's like that arc in red.
Okay. So,
Like this is the
I'm
arc
just trying to read this.
that corresponds to that angle right there.
Okay. So,
So let me draw an angle. Now, I'm not necessarily drawing an angle that's 1 radian.
is this on a unit circle?
Yep, this is going to be a unit circle.
So it's 1.
So ideally, yeah, I'd like to get it as close to the center as I can. So that is 1 unit.
Okay. So that means
And
1
let's draw
radian.
another one over here. That's 1 unit. So now, what does this say? It says that if you were to measure, like if you put a protractor on that,
Yes.
and you were to measure that in radians, you would get a number.
Do protractors have radians on them? You should
Yeah,
add
there
that.
might be some with protractors with radians. So if you measured that with a protractor, you're going to get a number.
Yeah.
If you took a piece of string and you put it like that, and you measured it, you would get the exact same number as you did with the
Oh,
protractor.
so it's like the degrees.
Well, it's be well radians. Yeah.
Well, it's
Okay. So again, take a protractor. Let's measure that, and let's say it comes out to
45 degrees.
4.5.
30 times harder.
Okay.
Degrees.
I don't understand.
I did make.
You know, listen, some of you aren't
Are you
listening.
measuring in radians?
Yeah.
Oh.
So let's say you, again, take a protractor and measure that.
Yeah.
Let's say your protractor gives you 4.5. Take a piece of string, put it on the circle like that, and then after you do that, straighten it out, put it on something to measure. It's going to also come out to 4.5. If you take a protractor and you measure that and it comes out to 3.6, and you take a piece of string and you put it on that, that piece of string is also going to come out to 3.6. This number and that number always come out exactly the same on a unit circle.
And that's how many radians?
That's what this is saying.
Now, does it matter what unit you use?
No, it would just be the whatever unit for that. Depends on what unit that is. Is that 1 inch, 1 foot, 1 centimeter?
It's all just going to be consistent.
Yeah.
Okay.
So whatever unit, if you're measuring and saying this is a circle of 1 foot, then when you measure your piece of string, you measure it in feet. But the unit can be anything you want.
So how does this help us
Right.
determine how it relates to degrees?
So let's see how we can figure that out. So everybody see how the measurement of this angle and the measurement of the length of that piece of string would be the same.
Yes.
Just on this circle, but that's fine. It only needs to work for this circle. If those things come out the same, right now we don't know how to figure out angles and radians, but we do know how to figure out that. What is that thing that I just traced?
A circle. Unit circle.
What about the circle is
It's
it?
1, 2, it's 2 across.
It's the circumference of the circle. So in other words, if you can find the circumference of that circle, that'll tell you the distance all the way around it.
Would it be 300?
It will also tell you the distance of the angle that goes all the way around it, because they are the same. So if we can figure out the circumference using a formula we already know,
Wouldn't that be in inches?
then we're going to know the size of the angle that goes all the way around the circle. So let's figure out the circumference.
It has
what-
to do with pi, right?
It has to do with pi. Does anybody remember the formula for circumference? Yeah.
Is it 2 pi r?
2 pi r. So let's find the circumference of the unit circle. What am I going to plug in for r?
Can I eat it?
1.
1. When you multiply 2 pi times 1, I'm not worried what 2 times 3.14 is. just do 2 pi times 1. The circumference of that circle is 2 pi.
So you don't want this like between decimals?
No, we're just going to leave it with pi.
Okay.
So we know the circumference of that circle
2 pi.
is 2 pi. That circumference is the same as the angle in radians.
Wait. What?
So our arc is so big, it's now a circumference.
How did it change to circumference?
Our arc is a circumference. I know, our circumference is just an arc that's so big it goes all the way around.
Yeah, but we have a smaller than all the
They
way
took the
around.
whole thing.
Yeah,
Talking about that angle.
I'm talking about this whole thing.
Oh, okay.
So if we measure this circumference, which it is an arc, it's just a really big arc, called a circumference. If you can find the length of that arc that goes all the way around the circle, it's exactly equal to the number of radians that go all the way around the circle. So what was the circumference of that circle?
2 pi.
2 pi. So how many radians?
2 pi.
It's
2 pi
two-
radians.
Yeah, it's 2 pi radians.
I don't.
Find the circumference, you find the radian.
No,
Yep.
you find
On a unit circle, the circumference is the radian. It's exactly the same.
How does that relate to degrees?
So
Oh, 2 pi radians is 360 degrees.
to go all the way around the circle, it's 2 pi radians, and we know in degrees it's 360. Now we've got a connection between radians and degrees.
That's a
And that's
terrible
just a unit
connection.
circle.
So that's like saying in 1 foot there's 12 inches.
That's a terrible connection.
In 360 degrees, there's 2 pi radians. Yeah, it's not a nice number, but
Can we make 2 pi into a nice number? What's 2 pi?
no, we just gotta call it 2 pi.
Pi twice. What's pi?
The
twice?
Greek letter for pi, that is the nice way of writing
It's just
3.14159.
2 times pi.
Yeah, that's how many radians in 360
There's my
degrees.
number right there if you want to
Yep.
multiply it.
And even though we proved that using a unit circle, that applies to any size circle. Like if I took that web page and made it smaller, there would still be 2 pi radians in 360 degrees. Okay? That's a true fact, all the time.
Where's pi on my calculator?
We'll talk about where the pi button is because we're going to use it in a little bit. Yeah.
So does that work for like any like angle? Like would 180 degrees be like pi?
Yes. Yep. If you went to 180 degrees, if you look on the board, it shows it as pi. Yep. So you'll see that some angles it shows as a pi, and then some of them it shows it as a decimal. The way this program works, generally if it's a multiple of 30 or 45, it shows it with a pi in it, like that. And there's a reason why they do that. 30s and 45s are common, so they tend to write them with pi. An angle like 34, not very common. They usually write it with a decimal. As far as whether you needed to use a decimal or not, I would always say that in the question. Either write your answer as a decimal, or I would say write your answer with pi in it, like that. Right, so let's write that down now that we know we can fill in the question mark. 360 degrees is equal to 2 pi radians. Let's see if we can make that a little simpler. Okay, saying that 360 degrees is 2 pi radians, it's kind of like saying in 5 feet there's 60 inches. It's true, but it's not as simple of a fact that I could have said. Does anybody see something I could do on both sides just to make the numbers smaller?
Divide by 2.
Yeah, we could divide by 2. And I think Caleb said that earlier. 180 degrees is pi radians. Okay, that's better. But generally, when you give somebody a conversion between any two things, minutes and hours and days, there's usually a certain number you try to put in the conversion.
One.
Yeah, usually you put a 1 in it. Like if you're going to say, well, how many hours in a day? You say 24 hours in one
Well,
day.
can you just divide pi by 180?
Yeah, so what we're going to do is we're going to get a 1 on one side of this. Depending on which side we put a 1 on, it's either going to convert from a degree to a radian or a radian to a degree. Let me see which one I want to do first.
Degree to radian.
Let's do... Yeah, let's do degrees to radians first. All right, so degrees to radians. Let's see if we can get a 1 on the left side. Okay? So I need to divide by something on both sides to do that.
180.
Yep, let's divide by 180. Divide by 180. What's 180 divided by 180? 1. So that becomes 1. You still have the degree symbol. That is how many radians in 1 degree. Now, let's say I didn't want 1 degree. I wanted a formula for 2 degrees. What could I do on each side of that?
Multiply by 2.
I could multiply by 2 and 2. And now if you did that out, it would say 2 degrees equals, and you have a calculation on the other side you could do. What if I wanted a formula for 5 degrees?
5.
You multiply by 5 and by 5. So now it would say 5 degrees equals, and you have something you can type in on your calculator. It's not important what number you put in the blue box. What's important is this. That's the conversion between degrees and radians. Whatever you're trying to convert, you multiply by pi and you divide by 180. That is how you change a degree to a radian. Whatever number is in that box, multiply it by pi and then divide it by 180. Those are the 2 steps to change degrees to radians. Now, to do radians to degrees, it's very similar.
Wait. So if I'm trying to find 60 degrees in radians, I do 60 times pi divided by 180.
60 times pi divided by 180. Yep, and then we can reduce 60 and 180, but we're going to do that next. Yep, that's how you convert.
Fascinating.
Why didn't we start with this?
Well, we didn't know how many radians in a circle.
Well, somebody could have told us.
If we knew that, I know, I was waiting for you to tell me. I couldn't remember, I had to figure it out all
Oh,
over.
yeah.
That's a big lie.
All right, now, let's look at the same formula again. What side did we get a 1 on last time?
1.
The 180 side. Let's get a 1 on the,
Would you divide by pi?
let's divide by pi. Pi's cancel. What's pi divided by pi?
1.
So 1 radian equals 180 divided by pi degrees. So now if you want to know exactly how many radians, or how many degrees in a radian, just take 180 and divide by pi. We already knew it was between 57 and 58, but that's exactly what it is. 57.296. Yep. Yeah. All right. Now, let's say you don't want to convert 1 radian, you want to convert 2 radians. What could you multiply each side by?
2.
And now if you did that out, it would say 2 radians on the right, and you'd have a calculation on the left. What if you wanted a formula for 6 radians?
Then there would be a 6.
Yeah. Multiply the right side by 6, multiply the left side by 6, and you'd have 6 radians equals, and then you'd have something you can do up.
So to figure out how many degrees in 1 radian you do.
So that's what's important this time. To convert from a radian to a degree, you take whatever's in this box, and you're going to multiply it by what?
180.
Multiply by 180 and divide by pi. Yep.
So if it's like 0.87 radians, I do 0.87 times 180 divided by pi.
Yes. Yep. So that's the 2 steps to change a radian to a degree. Multiply by 180 and divide by pi. Okay, so it can be kind of easy to mix those up. One's multiply by pi, one's divide by pi. So we gotta keep that straight. And the way you can remember it is Whenever I say degrees, when we're converting, I want you to think of the number 180. When I say degrees, think 180. When I say radians, think of pi. If you can remember those two things, it's going to make all those steps automatic. All 2 steps. All right. So degrees, think 180. Radians, think pi. Any questions on those 2 steps? Now we're going to try some examples. Okay. So convert to radians. Okay, so I've got 60 degrees. Kind of helps if you think of it as a fraction. You don't have to, but you're going to multiply by a fraction, so just try to think of it as a fraction. You have 2 options for what you're going to multiply by. It's either pi over 180, or it's 180 over pi. It's one of those 2. Look at, where is degrees in the fraction now? It's in the top. You're trying to get rid of it, because you want to end up with radians.
So 180 has to go.
So where would degrees have to go to cancel out?
Can't we just do it on our calculator?
No.
No?
Yeah, you'll see why. Because I don't want any decimals. No decimals. So you have degrees in the top. To cancel it out, you need degrees in the bottom. What number did I say to always think of when you think degrees? When we're converting, yeah, think 180. And that means in the top, we're going to have radians. And what number do we think of with that? Pi. One thing you got to kind of get used to, though, is I had put RAD on the other screen. They never put RAD. So how do you know if something's a degree or a radian? Well,
The degree sign.
the degree sign. If you see a degree sign, then you know it's a degree. If they don't put a degree sign, then it's the other thing. It's a radian. Okay. Now, when we multiply that, we're just going to leave our answer exact. What number goes into 60 and 180?
60.
60. How many times does 60 go into 60? Once. How many times does 60 go into 180?
3 times.
3 times. Now multiply straight across. What's 1 times pi? 1 pi. What's 1 times 3? 3. That's how you write your final answer. 60 degrees is pi over 3 radians.
Can you add the 1 if you want?
Now I can check it by going like this, and it shows you. 60 degrees is pi over 3 radians. Can you add the 1?
Like, can I just write 1 pi?
Sure.
Why did you put
You could put a 1 pi over 3. Yeah.
why did you get rid of the degrees in the bottom?
The degrees canceled out because you had 1 in the top. I should have crossed it out, but you had 1 in the top, 1 in the bottom. And that was the goal. You wanted the degrees to cancel out, so you ended up with radians. Let's try another one. 150 degrees. Okay, where's degrees going to go to cancel out?
The bottom.
Bottom. What number do we always put with the
180.
degree symbol?
And then pi.
And then pi. Now, if you type that in on the calculator, which we are going to in a little bit, but not this one, you're going to get a decimal. I want to reduce that as much as I can, but no decimal. What number goes into both?
10.
You can do 10, yeah, so that would cross your zeros off.
30.
And then what number goes into 15 and 18?
3.
3. So you could have done 30 originally. 3 times what is 15? And 3 times 6. And now multiply straight across. What do you get in the top?
5 pi.
5 pi. And in the bottom? 6. No label of RAD. Okay. If I check 150 on here, you're going to see it doesn't put RAD. It just writes 5 pi over 6. No RAD. Any question on it? Okay. Let's try this one. So with a negative angle, doesn't change anything. If you're starting with a negative angle when you convert it, what kind of angle do you think it's going to still be?
Negative.
Still going to be negative. Okay. So let's do it the same way. Just don't forget a negative when you're done. Okay. What
I'm sorry.
I was jamming, why'd you turn it on?
what goes in the bottom?
180
180
degrees.
degrees. So that way we can cancel degrees in the top. And then what goes in the part that's
Hi.
pi?
You add one to the bottom.
I could, yeah, if you want to flip the one. Yep. What number goes into 45 and 180? 15, yep. How about a bigger one? 45. How many times does 45 go into itself?
One.
Into 180? 4. So if you multiply straight across, what's negative 1 times pi?
Negative pi.
Negative pi. And in the bottom, what's 1 times 4? There you go. So negative 45 degrees should be negative pi over 4. There you go. Okay. All right. Questions on that?
No.
And let's do one more, and then we'll try converting the other way. Actually, no, I want to try one on the calculator too. Okay, what do we multiply by for this one? Pi. Divide by 180. Again, I don't always put the 1 in the bottom because I just know it's there, but you can put it if you want.
And then it's gonna be 1 over 2 because 90 goes into 180 twice.
2. So 90 degrees would be how
Pi
much?
equals, or sorry, pi divided by 2.
Yep. So 90 degrees should be pi divided by 2. There you go. Pi over 2. All right. All of these answers are what we call exact. They're exact because there's no decimals. Let's try this one, and let's round to 2 decimal places. Okay. How do you know if you should round to 2 decimal places? It's going to say it. Yeah. If it doesn't say round, then you always leave your answer with pi. Yep. Okay. So rounding to 2 decimal places doesn't change how you do it. Put it over 1 if you want. What are we going to multiply by? We're going to divide by
180.
180. What cancels out there first?
The degree.
Yep, degree in the bottom, degree in the top. And now we're just going to multiply out what we have left. Okay. When you do this, do not use 3.14. Okay, you want to use the pi button.
So we do this type of problem on a calculator?
Yeah. When it says round to 2 decimal places, you have to. Yeah.
Second, and then the, what's it called?
Yeah, second and then the exponent button. That's how you get the pi. If you use 3.14, it will throw off your answer.
So is that 107 divided by pi?
No, 107
Times pi.
times pi.
Times-
The only thing you're dividing by is the 180.
Alright, and then you just divide that by 180?
So 107 degrees is about 1.87 radians.
8. Yeah.
How did I not get that?
All right. And then if we check it, let's go to 107. 107 degrees is about 1.
107, I typed 107. Oh, silly goose.
Okay, so that's converting to radians. Now, let's try it the other way. I'll write RAD the first time, but after this, we got to get used to not seeing that there. So convert from radians to degrees. Okay, where is RAD? It's in the top. We're not going to see it after this problem. You got to pretend it's there. So RAD is in the top. To cancel it, we want to get rid of it because we're trying to get degrees.
Pi's gonna go on the bottom.
So the radians has to go in the bottom, which
And
means
180 on top?
pi goes on the bottom, 180 goes on the top. What cancels out there?
The degrees and degrees.
No, degrees doesn't cancel. Pi cancels. What else?
There's 6.
That reduces, but there's something else that cancels.
Radian?
Yeah, and in the future that's going to be invisible, but we know it's gone. Now you're left with 180 divided by 6. how much is 180 divided by 6? 30. Yep. 180 divided by 6 gives you 30 degrees. You do need to put a label on that. If you don't, what did I just write down?
30 radians.
I wrote down 30 radians. I give you half credit because you did some math right, but you put the wrong label completely.
You didn't write down 30 radians, just 30.
Yeah. Well, if you write the number 30, it is radians. When you're talking about angles, it is radians. It's like writing 30 inches versus 30 feet. It's a huge difference. All right, let's try this one. Now we just have to understand where radians is. Where is radians in the one on the left?
To the right.
Well, is it in the top or the bottom? It's in the top. It's right next to pi.
So it's going on.
So
What
it
is the
need-
2?
So this needs to go in the bottom
Yeah.
to cancel out. RAD is next to it, but it's invisible. What needs to go in the top?
180.
180. Okay, radians cancels out. That's next to pi.
It's gonna leave you with 30.
What else cancels?
The
The
pi.
radian.
The what?
Radian.
Well, the word RAD is gone. That's invisible.
The pi.
The pi's cancel.
Why wouldn't the 2 be radians, because there's no label?
Because there's no, well, when you label a fraction, you only have to put the label in one spot. So usually we put the label next to the pi symbol. The label always goes next to the pi symbol. Yeah. It's kind of like if you have a negative number in a fraction, and you can do that, or you could do that. Either way is okay. We usually put it in the top though. That's more typical. Same idea. Okay, so that cancels. Now we've got 2 divides into 180. We can reduce it. How many times does 2 go into 180? 90.
Times 30.
So you're left with what?
90 times.
3 times 90 degrees, which is?
180, no.
27, 270.
Like the whole answer, how you would write it on a test.
270 degrees.
270 degrees, yes. So the way you do the degree symbol in Edge Elastic, you'll click in the box and it'll pop up. Good. Any question on that one? We can check it. I haven't been checking a lot of them, but 3 pi over 2 is,
Can we use this tool
Right
for
there.
our test?
no.
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 Yeah, you can definitely use it, yeah.
So that's just showing you. Yeah, you can use it like this with a lock on that. And when you get really good, you can take the quiz and you figure out where the angles are.
Take the quiz.
All right, maybe I'll let somebody try to take the quiz after.
Will you want to do it?
All right, let's try this one and then I want to do a calculator one.
Zach, you said you wanted to do it.
Thing about the quiz is it's kind of precise, so if it's like 45 degrees and you're off, like, it accepts a little bit of error, but if you're off too much, then it just marks it wrong. It doesn't have a lot of tolerance. Okay, so negative 3 pi over 4, convert 2 degrees. Where would radians go?
On the bottom right.
Right, so you want to cancel out the pi. And what would go in the top?
180.
180. Okay, so what's going to cancel out first?
The pi's.
Pi's cancel.
Invisible radians.
Invisible radians is gone. And what's going to reduce?
4.
How many? What,
45.
what number goes into 4?
4.
One time. And how many times does it go into 180? 45. So what are you left with?
Negative 135 degrees.
Yeah, negative 3 times 45, or negative 135 degrees. Now, all these answers on this page, are these approximate or are these exact?
Approximate.
Well, if they were approximate, I would have done that. So you would have seen that symbol. And second, are there any decimals? Like, did I round these off? No, I didn't do any rounding. For the last one, let's round it. Okay, so 3 radians. It's not a fraction, and it doesn't have pi in it. That's fine. That's like saying, well, the number 13 doesn't have a 4 in it. Okay, so not every number has to have a 4 in it. Not every radian has to have a pi in it. Can or cannot. So we know it's radians though, because the directions say convert from radians.
So instead of just being imaginary pi.
So what would you
No, there's
multiply?
no pi. It's not imaginary.
So what would you multiply by? What would go in the top?
180.
180 always goes in the top when you're converting to degrees.
And then pi on the bottom.
Pi goes in the bottom. Okay. Whatever unit you're trying to convert to, that goes in the top. Think of like the top is beta, right? Top is just the one you're going to end up with. Okay? Whatever you put in the top, that's the answer of the unit. So radians is gone. Does the pi cancel? No, there's no pi next to the 3 to cancel it. So we're going to multiply 3 times 180. And we're going to divide by, how am I going to type that in?
Divided by pi.
Divided by pi. So to 2 decimal places, I'm just going to write that down. What would that be to 2 decimal places?
8.9
171.89. And the unit?
degrees.
Degrees.
It is what it is.
Now, let's say that you didn't use the pi button. Let's use 3.14. And let's say I am going to grade it, for full credit, that you round properly. If you take 3 times 180 and divide, what is that, 540, divided by 3.14, you get 0.97.
Oh.
Okay, 0.97 and 0.89, they're not the same number. All right? So there's a big difference. So make sure you use the pi button. Okay. Any questions on converting between radians and degrees?
Probably tonight with the homework, but not at the moment.
Okay, well, you only have 2 options. It's either 180 over pi or it's pi over 180. Those are the 2 all the time.
I got it.
And I think Will should be.
Okay, so that's homework for tonight. Remember, we skipped the rest of chapter 1 because it's not really material we cover. Or
Radians is what, 1.2?
this is 2.1. So we're doing the first section in chapter 2. We're going to stay in chapter 2 for the next couple of weeks. Yeah, all of this week, all of next week.
Didn't Will take the test? He said he's confident.
So 36 to 68 even. Some of those you're converting exact. Some of them you're converting as decimals. Some you're converting to radians. Some you're converting to degrees. But it's everything we just did.